Hello everyone. So today we're going to discuss about the and very important part of inequalities. Very important part of inequalities that we known as the wavy curve method. The name suggests that there was something like this wave. No, the name only suggests that there was some wave like this. Now, are there any waves here? We'll try to find out. So we all know how to solve inequalities. Let us first try out some. There's one. 2x minus 1 is lesser than 3. Okay. What will it become? 2x lesser than 4, which implies x is lesser than 2. Okay. So if we okay, if we take the number line, then if we take this is 2, then there will be a hollow and we will continue till there. So it is how to we represent it on the number line. So we have done this now. We've done many times these problems indeed. Now see, these inequalities are very good. And what will you do when you get a quadratic? Suppose x square minus 5x plus 4 is a quadratic which is greater than equal to 0. We'll get x square minus 4x minus x plus 4 greater than equal to 0, which implies to x minus 4 into x minus 1 is greater than equal to 0. Okay, it is correct now. We'll try about it, okay? X minus 4 into x minus 1. So what will it do? We'll take the number line. Where's the number line? This is our number line, okay? And we'll take the points 1, we'll take the points 4. Let's say there's a hollow there and the hollow there. What this means? X is only greater than or equal to 4. Is this the answer? No. For this type of problems, we need a very dangerous thing that we know as the wavy curve method. Means there will wave like this. Now, how will this wave help us in finding our solutions? We will try to find it out. Now, let's move on to the first basics of wavy curve. Okay. Now, if you have any doubts and inequalities, just finish it up. Then I'll advise you to come to wavy curve method because inequalities is the main part of this. And this wavy curve method is very important in functions such as greatest integer, mod, and many more like this. Okay. Now let's move on to the basics of wavy curve. Suppose a math is given x minus 1 into x minus 3. Now first we'll learn the basics, then we'll get onto the curve. First we won't draw the curve as it will cause problems to us. Therefore, at the very first point, we'll try to draw the basics. X minus 1 into x minus 3 is greater than 0. Okay, the color red is not good. Let's take it pink. Pink is not visible at all. Okay. Okay, pink is not visible. We have to take the color. Okay, this color will suit. Okay, this is visible. Okay. Okay. Now we'll plot the points 1 and 3. Suppose here. We start from our right side. Okay. Is this the right side? And go to the left side. We'll write a positive plus. Plus is always positive, no? Can plus be negative? No, it is always positive. Okay. Now see, we write a plus. Then there is 3. Okay, so this part between 1 and 3, this part belongs to this x minus 3. Okay, and this part beyond 1, it belongs to x minus 1. This part, it doesn't belong to anyone, actually. Haha. So, what we do is 1 and 3. What is 3? So, here is plus, then here there will be a minus. And then again plus. Then, so we get this region as positive and this region as positive. And they told us to find the value in positives. Okay, so what we will give the answer? X belongs to, we write these notations now. We have learned these notations in inequalities part. Okay, x belongs to minus infinity and 1. Which in union, okay, you might not know the what do you mean by union, but we have done it. Sets, and it is actually the concept of sets. Okay, but we have learned it in inequalities because we need this in inequalities actually. Union 3 comma infinity. Okay, so we've learned it now. Don't say you don't have. This is our answer. Okay, so this is the basic way we can do a wavy curve. Um, okay, let's try to solve another question of the same type. The question is 2x plus 1 into 4x is greater than equal to 0. How can I do that? You know, the rule of a wavy curve is that this part, the first x part, it should be single, means the x's coefficient could be 1, and the power, the power or the exponent should be 1. These two are the major factors that we do in a wavy curve in order to follow. But here what do we see? We see that there is a 2x. So how can we remove it? By removing it, we have to equate this to 0. If we equate this to 0, then we'll get x equals to what? Half minus half. Then we'll bring it that side, then x plus half equals 0. Then we will clearly write just x plus half into 4x is greater than equal to 0. What we'll do as a 4x? We do is that we divide both sides by 4. What will we get? X plus half into x is greater than equal to 0. You might be thinking, why do we equate it to 0? I'm just showing you the broad steps. The broad steps that we missed here. Okay, the steps that we missed here are 2x plus 1 into 4x is greater than equal to 0. We take 2 common, x plus half into 4x is greater than equal to 0. Then we divide both sides by 2. 2 into x plus half into 4x whole divided by 2 is greater than equal to 0 by 2. Okay, what does it implies? X plus half into 4x is greater than equal to 0. This part is what we missed here, okay? Only and only this part. What do they do? We missed this part here. Now moving on, what we get? We get it as x plus half into x is greater than equal to 0. We'll draw what? We'll draw the number line. We'll draw the number line. Well, what do you know? How did I find the points here? We just equate it to 0. Then we'll get the point 1. Then we'll get the point 3. That's how. So here the same thing we'll do. Okay. So here the same thing we'll do. We'll just equate it to 0. If we just equate it to 0, then we'll get 1 point as minus half. And if we just equate x is to 0, that will be 0 itself. Then we'll put another point 0. And then the rule of number line, you must know that it goes greater than from this way to this way. This is the rule. Now see, now we'll do normal, here plus, here minus, here plus. Okay, now you know why it is wavy curve, but we haven't used the curve anywhere. Here I've talked about the wavy curve. How did the wavy curve come? Most of you who are very smart must have understood that it goes something just like this. It's a bit bent out, but what can I do? So now, since it's greater than or equal to 0, we get the positive symbols. Then x belongs to what? Minus infinity, comma. We'll take minus half in closed bracket. Why? Because if we put the value of minus half here, then it becomes 0, and 0 equals 0 now. Then it will be minus half in closed bracket, and we'll get the union symbol, and we'll do it as, but 0 is also eligible now. 0, comma, infinity. That the two were. So this is our solution set. We did this problem, so what do we now know? If someone tells you, write the basic formulas, plus for what? For wavy curve method. What will you write? We'll write the first that each coefficient of x must be 1. The power of x everywhere should be 1. So until now, we have learned these two processes. Actually, are these processes? No. Until now, we have learned these two formulas. We'll discuss more on. Okay, so until today, we are doing up to this basics. Next day, what we will do is we'll discuss about power in wavy curve. Okay, how does the power in wavy curve works? We'll discuss in the next class. That is, we'll discuss problems like x plus 1 whole square into x minus 1 whole divided by x minus 3. We'll discuss some such type of problem. Okay, no. First, we'll discuss these problems. If something is in fraction, it is in fraction. Okay, then how can you do it? How can we do it? And next, we'll discuss about the power ones. Okay, we'll discuss the power ones and then we'll intermix together. Okay, So thank you for watching this video. Goodbye, and it is 11:33. Therefore, good night. Thank you.